Alright, we're going to learn a new way to get volumes of rotated solids. Instead of using discs and washers, we're going to use shells. And the way shells work are kind of like this set of stacking cups here, okay? So each cup is a shell and each one stacks inside the other. And when I put them all together, I make a solid. How do we get the volume of each shell? Well, think of each shell like a sheet of paper, okay? It's really, really thin. And the volume of the sheet of paper is the length times the height times the thickness. And the thickness is going to be dx. Okay, how are we going to get the length? Well, if I make it into a cylinder, so it's a shell, then that length is a circle, and the circumference is 2 pi r. So the volume is going to be 2 pi r times the height times the thickness. So that's what this picture is representing, okay? Think of this as a sheet of paper turned into a cylinder, and the length of the paper is 2 pi r, the height is h, and the thickness is dx. So the volume is going to be the area of the paper times its thickness, which is 2 pi r h. So let's apply this to an example. Let's revolve this parabola around the y-axis. Okay, so here's my y-axis, here's my x-axis, and 4 minus x squared is going to cross, well, hang on a minute. Let's spread this out a little bit. It's going to cross the x-axis at -2 and 2. It's going to cross the y-axis at 4. So it's doing this. We're going to swing this thing around the y-axis. Okay? Now, instead of stacking discs one on top of the other, I'm going to build a shell. And we're stacking them one inside the other. Okay, so this shell is going to go like this. And it's going to swing around. And the bottom is going to go like this. And it's going to swing around like that. Now the thickness of this shell is dx. The height is y, because it's coming out to a point x comma y. And the radius is x. So the volume of this red shell is 2 pi r h dx. R is x. H is y. Well, what is y? Y is 4 minus x squared. So I have 2 pi x 4 minus x squared dx. And if I distribute that x, I get 2 pi 4x minus x cubed dx. So to get the total volume, we're just going to add up all those shells, starting at the one in the very center, which is at 0, and going out to the one in the outermost point, which is at 2. So our total volume is the integral from 0 to 2 of 2 pi 4x minus x cubed dx. And let's just pull out the 2 pi, and we'll do the rest on our calculator. So I hit Math 9. I'm going to go from 0 to 2 of 4x minus x cubed dx, and I get 4. When I multiply 4 by 2 pi, my final answer is 8 pi. All right, let's do one more example. This time we're going to work with y equals x squared, which is our basic parabola, and x equals 2, which is a vertical line. And this point here is going to be at 2 comma 4, and we're going to y equals 0, which is the x-axis. So we're going to take this area right here, and we're going to rotate it around the y-axis. It's going to go around like this. Okay? And so this area is going to swing around over to here. And I've got a bunch of empty space in the middle. But the cool thing about shells is that it's not like washers. It'll just take care of the empty space automatically. Okay, so this is going to come around here. All right, now let's draw a typical shell. So it's going to go around like this. And here's the bottom of it. The thickness is dx. The height is y. The radius is x, because this point is at x comma y. So the volume of that shell is 2 pi times the radius, which is x, times the height, which is y, but y is x squared, so I put that in, and then times the thickness, dx, which is 2 pi x cubed dx. Okay, so the innermost shell, the one in the very center, is at 0, and the outermost is at 2. So my total volume is 2 pi integral x cubed from 0 to 2 dx. That's easy enough for us to do by hand. That's going to be x to the 4th over 4 from 0 to 2, which is pi over 2 x to the 4th from 0 to 2, which is 16. Put in 2, I get 16 times pi over 2 is 8 pi. Put in 0, I get 0. My answer is 8 pi.